Hello, my name is Marc Braun from Jasper High School, and welcome to our special program this afternoon. We're going to be talking to you about the rapid prototyping program we have at Jasper High School. With us this afternoon are LB Boeglin, Dreer and Andrew Kieffner, and we're going to be talking a little bit about what our class is doing with this technology and how it's working for our students in our community. Let me start by saying that rapid prototyping is a process that's used to get from a CAD file or a computer drawing to a 3D part of whatever that CAD drawing is. So if we draw something on the computer, we can then in one step print it out using a printer, just like you might print a color image of a photograph you've taken on your color printer. We can print a three-dimensional object using plastic. And so these guys are here to talk to you. They're coming from our Senior Engineering Design and Development class, and they're here to tell you about how this process works. So I'm going to turn it over to them. LB, what exactly is a rapid prototyping machine or a 3D printer?
Well, like Mr. Braun said, a 3D printer is also known as a rapid prototyping machine. A rapid prototyping machine is the automatic construction of a physical object using solid freeform fabrication. Basically, how it works is depending on the size of the part you want to print, the printer itself will figure out how much material, support material, things like that it needs to use, and then it will lay down a layer of support material. I don't know if you can see it here or not, but there's black support material here on the bottom that supports this whole piece. Then what it does is it goes through layer by layer, putting little bits of plastic on it until it finally gets the part completely printed. Then we take this part and we put it in solution to dissolve this support material, and we have our finished part such as this. The material that the rapid prototyping machine uses is something called ABS plastic. ABS stands for acrylonitrile butadiene styrene. And yes, that's a very long
Otherwise
word.
known as ABS, right?
Yes, very good. Depending on the size of the part, it takes usually 2 to 12 hours to print. We got this machine last year. A company let us borrow a machine to try it out, see if we liked it or not. And then we held a meeting for local industry a few months later to see if they'd be interested in helping us support this printer. And once we found out that the companies would support us, they'd use it, they'd come to us to get their prototypes, we decided that we'd go ahead with the next step and figure out a way to acquire this machine. And that's basically how we acquired this rapid prototyping machine.
LB, let's go back to the material a little bit. When you're talking about ABS plastic, we brought a print cartridge, and a lot of people are familiar with what a print cartridge looks like for their black and white or color printer. Well, this is what a print cartridge looks like for our rapid prototyping machine.
Yeah, it's basically just an oversized cartridge, except instead of having ink in here, it has a long coil of plastic. And I'm not quite sure how much plastic is in each one of these cartridges, but this is basically what it is here, except a lot longer.
We're actually looking at 53 cubic inches of material available in the print cartridge itself. Once the plastic enters the machine at a little bit thicker, it's almost like a weed eater line. If you have a weed trimmer you use in the yard, that's just about the consistency and the thickness that we have. Once it reaches the print head of the machine, it becomes to a thickness in the vicinity of 0.010 of an inch, and then that's how our parts are printed with such a high degree of detail and accuracy. Andrew, maybe you could tell us a little bit about the applications for this machine and this process in our local industry.
Well, say you need to make a 3D model of some sort. With the rapid prototyping machine, all you do is you go ahead and create it on a STL file, and you easily can express your idea with a 3D model.
Derek, maybe you could tell us a little bit about how old this technology is, how long this has been around.
Well, the first techniques used for rapid prototyping became available in the early 1980s and were used to produce models and prototype parts. But today they're used on a much wider range of applications and are even used to manufacture production quality parts in relatively small numbers. When talking about this rapid prototyping machine, we brought a few examples along with us. This week, I was given the sketch of this column support right here. Hold that. And then I got on a CAD program called Inventor and just basically sketched it up and then saved it as an STL format file and then inserted it into the machine, and it just printed itself off. It took roughly, I think, 8 hours, but it's amazing how you can just go from this on paper to this 3D model.
Another thing that the rapid prototyping machine can do is it can actually make movable parts. If you can notice here, there's a knob, and this actually turns, which is quite amazing because you wouldn't think a printer would be able to make a part that can move. You would think it'd all be stationary, but in reality, we can make anything. We could basically model anything that we had a picture of.
In fact, right now at school, we've just been to a website and downloaded a file, and we're about to print a copy of a human ear and make that copy out of plastic. So there's all kinds of other applications that aren't just mechanical engineering or mechanical in nature.
If you or someone you know has a talent to showcase or an event to promote on 27 Topics, please contact this station.
Welcome back to our special program this afternoon on rapid prototyping. I'm here with Logan A. Strike, Kurt Breitwieser, and Clayton Terwisky, all students in our Engineering Design and Development class at Jasper High School. Engineering Design and Development is our capstone course of our pre-engineering Project Lead the Way program. This is a program that's going to help students succeed in a pre-technical or technical collegiate environment or engineering environment in college. So these guys are our future engineers and technicians. Hopefully they'll come back to Southern Indiana and have great jobs and work with us down here. Logan, how exactly would you go about making one of these parts?
Well, I'm a pretty artistic person, so first to get the ideas out of my head and down on paper so I won't forget them, I will make a drawing with a pencil. So then from that, I'll make the dimensions that I might want to make it and then go into the computer using our Inventor software that we have and I will make the image in 3D on the computer, or if so, a digital image. Then from that, I'll have to save it as an STL file, which means standard tessellation language. If so, if you will, it means basically it makes a language that the rapid prototyping machine will understand. So then from that, I'll upload it into software that I can move the part around in different places so that I can make the part. And if you look at this plate right here, I can, in the computer, place the part wherever I want it so that I know where it's coming out on the machine. So I'll do that, and then from there I'll upload it straight into the machine, and then within a couple hours or so I should have my part.
Logan, how did you learn how to do all of this?
Well, this year would be my 4th year taking engineering classes, and I will have completed my 6th class total. So I've had a lot of experience with engineering and the software that we use, so I've kind of picked it up along the way. And I've also worked with many engineers at Kimball, and if I ever have a problem, I go to them, and they help me solve it if I can't find the answer myself.
Okay, Logan, you mentioned that you work with Kimball. You might just say a little bit about some of the other companies possibly in the area we're working with and the different projects we're doing with local industry.
Well, I know for one we're going to work with Air Ride for them making parts because they have to hand turn parts by machine. So they're going to come to us and we're going to make some parts on our rapid prototyping machine. And
that's Air Ride Technologies.
Yes. And we're also making parts for Ditto Sales that have come to us and asked us about them. And I'm not really familiar with some of the other ones. Somebody else might. You guys?
Leland Manufacturing, Best Chairs, I believe some of the other folks who are interested, Paoli Furniture, Jasper Seating, and there are a few other companies in town that were very interested in this process and using us to get from their CAD designs to a prototype. What we're able to do is work with them and they work with us, and they give us some donations, and we provide them then with their rapid prototype. They can email a CAD file to the school, to me, and we have made a brochure here as a bit of a school-based business, and has a lot of information about how this whole project works. And we're trying to distribute these throughout the community. And so companies can contact us, and we'll work with them to create these parts. And so far it's been working very well, and the equipment's practically been funding itself, paying for itself. Kurt, how would a business contact us at the high school? You might fill us in from your perspective, and how would we deliver a part then to a business?
Well, businesses will send an email to our rapid prototyping account, and they will already have set it up into the STL file, and we will just put the data into the rapid prototyping machine to see what it costs, and then give them the amount and see if they would like it. Then after that, if they accept the offer, we would print it out, and usually they would come to pick it up from the high school.
Okay. Kurt, how does this program, how does this capability benefit our technology club that we have at the high school?
Well, for the technology club, it's great for designing parts. Like, we have this fuel tank right over here. You can see how it's modeled. Then you can even go to fine detail. You can put threads on objects for screwing on caps, like this one. It has the capability you can put on and off a cap. And you also use it for wind tunnel testing, which we have at the high school.
Okay. Can you say a little bit more about that wind tunnel testing, how that's being used as a class project?
That's Clayton.
For the wind tunnel testing, we just acquired the brand new wind tunnel this year, and We have designed 2 different types of cars. We have this one right here that we made from the rapid prototyping machine. And this one, which we are going to use, this is our final design of a car. And we just place it in the wind tunnel, and it'll give us feedback on all the aerodynamic testing from it.
We'll test it at different miles per hour and different speeds to get a summary of data. And then at different speeds, we'll figure out what is best to run our car at versus aerodynamics. So that helps with that too.
Okay, you guys have mentioned this car. Clayton, maybe you can tell us a little bit about what they mean by testing for this car and a little bit about what our Super Mileage Challenge is.
Well, the last 2 years we've actually been involved in a competition known as the Indiana Super Mileage Challenge, which is a competition held annually in Indianapolis at Raceway Park. And basically what happens up at this competition is there's about 30 or 40 other high schools who they design and build their high mileage cars through the use of a combination of engineering, science, technology, and mathematics. And basically, they're trying to shoot for the highest mileage. I know last year, Modern Day actually won with, I believe it was 1,600 miles per gallon. So, I mean, the mileage really gets up there. We actually, the wind tunnel on this rapid prototyping machine really helps us out. This year, more than last year, we can actually figure out which of these designs. We already said we picked this one for this year. We can actually see how the aerodynamics flow over the vehicle and cut down on wind resistance, therefore increase fuel mileage.
Very good. Thanks, Clayton, for talking to us about the Super Mileage Challenge. Now, how does this technology, how does our machine benefit our engineering design and development class?
Well, we can take an idea that we have in our head or have it written down in our engineering journal somewhere. Just a simple sketch. We can place it on Inventor, and then from Inventor, save it as an STL file, which you've already said, and print the object in this rapid prototyping machine, and we can go straight from a thought in our head to a 3D model. And it's really makes us see how the world works and if our ideas are really going to work out in the end.
Guys, maybe each one of you could say something a little bit about our Project Lead the Way program, what it means to you as a student, and how you enjoy the program.
Well, this Project Lead the Way is actually very helpful if a student is planning on attending Purdue University or RIT or Duke University, and there's many others around the nation which actually accept PLTW courses for college credit. There are some stipulations, however. You have to finish the course with a B or higher, and you also must pass the final exam with a 70% or higher to earn the college credit.
I've been in the Project Lead the Way courses all 4 years. I took 5 of the courses here at the high school. I enjoy the courses. It's taught me a lot about different engineering programs that you can use and designing. I'm going to go to Purdue University and study aerospace engineering, which I'm taking the aerospace class here at the high school, so it's going to give me a head start on learning about all the aerodynamic flows and all that over airplanes.
I would just like to tell you that we've touched base on EDD here a little bit in aerospace. We have 6 classes at high school, at the Jasper High School. The first one you take is IED, which is an intro to engineering. And then there's POE, which is Principles of Engineering. And then from there you can branch off to either digital electronics or computer integrated manufacturing. And then the pinnacle, basically, the last class you would take is EDD, which is Engineering, Development, Design. And through all 6 of these classes, we get a really good basis and background so that our minds can think a certain way that engineers need to solve problems that the world may have, whether it's simple and complex, or simple or complex, and whether it might be obvious or far out there. So it really helps us get in that mindset.
Kurt, you talked to us a little bit about aerospace and wanting to be an aerospace engineer. Maybe you could tell everybody what these three things are here and how you've used them in the aerospace class.
Well, we created airfoils for our wind tunnel testing, see how the air flowed over wings and how the different shapes would affect it. Like you have ones with really far swept wings for higher lift, or you have symmetrical ones, which create like zero lift unless it's tilted at an angle. And we just saw what the best designs of different wings were and how they work for different planes.
Okay, so we were able to take an airfoil design, import it into our CAD software, print it out with our machine, and then take that design and put it right into a wind tunnel and test to verify if the results in the wind tunnel were the same as the projected results we got on the computer.
Yes.
Yeah. And so now, did you have any fun doing that? I mean, was that fun at all, or?
Yeah, it's really fun. We used the program on the computer that NASA created, and we got to learn a lot about different aspects of all aerodynamics and lift, and it was a lot of fun doing this.
Maybe just to wrap things up a little bit here, maybe you guys could tell us just about a few side projects that we've been working on that are outside of class, things you guys have been interested in that you've just created.
I have actually been working with a previous graduate from Jasper High School who graduated from ITT. His name's Jay Newhoff. And he has been researching about people needing a different part for a switch that switches from two-wheel drive to four-wheel drive. And he came to me and asked me if I could AutoCAD a part and make a part for him that would fit in there. So I reverse engineered a part that he already had and made it to his specifications so that it would work for him. And he was talking about maybe going farther with that.
I think we've also done a few iPod holders, and
Right here.
possibly, now this would be for
An iPod Nano.
for a car, for an iPod Nano, and a few other projects too that I think have been very interesting to see and get our students involved in the school. Well, we thank you for your time this afternoon and for joining us and hearing a little bit more about some exciting programs we have at Jasper High School. Thank you.